Hi, future doctors. Welcome to the next class. From now onwards, we will discuss capacitors. So, in this, what is meant by capacitor? What is the principle of capacitor? We will see. A conductor or a metal plate. A conductor or metal plate we have taken. This is going to be A. For this, if you have given some amount of charge, for the conductor or metal plate, we have given some amount of charge Q. So to bring this charge Q, you don't need to do any work. But if you want to give another charge for the second charge, positive charge or negative charge, then you have to do some amount of work. Why? Because already another charge is there. Whenever you are bringing the second positive charge, it is going to repel this. Next, if you want to bring another charge, you should do more work. So 1, 2, 3. If you want to bring another fourth charge, you have to do more work. Why we are bringing these charges? What is capacitor means? Already the device which is used to store the charge. The device which is used to store the charge or electrical energy. How electrical energy will be stored if you are bringing the charge? So here we have given 4 charges. Okay. So after giving 4 charges, capacity of this device is going to be complete. You can't give one more charge. But if you want to give more charge on this, what we have to do? So we have to do another uncharged conductor. Another uncharged conductor or metal plate, if you are taking, total charge of this one is 0. Whenever you brought uncharged conductor near to this, here, near the positive charge side, inside B, negative charges are going to induce. So this is uncharged, therefore, here positive charges are going to induce. So since negative charges, 4 negative charges induced, so 4 more positive charges you can give for this capacitor. We increase the capacitance from 4 charges to 8 charges by bringing an uncharged conductor near to the positively charged conductor or metal plate. Okay. Now we have increased the capacitance from 4 charges to 8 charges. Now still I want to increase. How much charge I am going to give? It has to take. And to give these 4 charges, you don't need to do that much work because it already these 4 are negative charges. What they will do means to increase more capacity. They will be doing ground. Whenever you are making ground, continuously here what will be developed? Positively charges because it is going to be making neutral. Continuously here negative charges. So therefore continuously we can give positive charges on this metal plate. Continuously we can. Therefore we have increased the capacitance by bringing an uncharged conductor near to the charged conductor, and one side of the conductor is going to be grounded. So this is nothing but principle of the capacitor. Now according to formula, this is theory. Now according to formula, how we are going to write? So whenever we are bringing charges onto this metal plate, whenever B is not there. So whenever we are bringing charge, what is going to be increased means to bring another charge, the amount of work done is going to be increased. Now, what is the amount of work done on the charge? That is only potential. Therefore, so if charge increases means what is increasing? Potential is also increasing. Q is directly proportional to V. So if we will write one constant here, that constant only, by removing this proportionality symbol, we will write one constant. That constant only C. Q is equal to CV. Here C is going to be capacitance, capacity or capacitance of the conductor. They are going to say C is equal to Q by V. Now, what is the unit for this? Coulomb per volt. This one only they will write farad, isn't it? Next, what is the dimensional formula for capacitance? What is the dimensional formula for capacitance means C is equal to Q by V. The charge dimension formula already we wrote AP. Potential. Potential definition V is equal to W by Q. The work done ml square T power minus 2 divided by substitute ml square T power minus 2 divided by 8. So m power minus 1 L power minus 2 T square is going to numerator T square. So 80 into 80 A square T square. Correct? Now finally you are going to write m power minus 1 L power minus 2 e power 4 A square. Correct? The negative dimensions in mass. So first year we got some physical quantities which are having negative dimensions in mass. So that is gravitational constant. Another one, compressibility. Another one, thermal resistance. That we are going to get all these. All these are having negative dimensions in mass in entire first year. In second year, presently this one we got capacitance is having negative dimensions in mass. Now this formula Q is directly proportional to V. Q is equal to CV. So in current electricity we will discuss Ohm's law. In 10th class also you might have heard voltage is directly proportional to current. V is going to be IR. So how this one will be helpful in resistor? Same like this it will be available. It will be helpful in capacitors. This one given by Ohm, therefore we will call Ohm's law. This one is given by no one, therefore you can take your name. Therefore I will call for student this is Ewer's law. So according to Ewer's law, Q is equal to CV. They are going to write. What is the symbol for capacitor? Same like this we will take. So one is plus Q, another one is minus. In some books they will write like this also. But most of the books you are going to take like this. Variable capacitor. Variable capacitor means so variable. This is the symbol for capacitor. Now, what is the capacitance of this parallel plate capacitor? How we are going to get it? They are going to take two metal plates like this. So one is given positively charged plus Q. Another one is given minus Q. So positive charge means metal plate. What is the direction of electric field? Electric field will be away. So while deriving this relation. The negative charge, electric field will be towards. Now see here in between the two plates, electric field will be both are having same direction. Therefore, this is E, this is E. Resultant electric field in between E is going to be E1 plus E2 you can take E1, E2. Now what is this E1? So if it is positively charged plate means, it remember sigma by 2 epsilon naught. Sigma by 2 epsilon naught plus sigma by 2 epsilon naught. Sigma by epsilon naught. What is sigma? Q by A. All these we discussed in first lesson. Sigma is surface charge density, amount of charge per unit surface area. Next, what is the relation between, separation between these two is small d, area of each plate is A. What is the relation between E, V and D? We came to know E is equal to, what is the relation we said? E is equal to V by, if you write here. So, V by D is equal to Q by epsilon naught. So from this, Q by V is equal to epsilon naught A by D. Now what is Q by V from this formula? Q by V is going to be capacitance. Therefore, what is our formula? So C is going to be equal to epsilon naught A by D. This formula you have to remember. What is epsilon naught means here? So vacuum permittivity or free space permittivity. A is area, D is separate. Now capacitance of parallel plate capacitor depends on C is equal to epsilon naught A by D. If distance between two plates increases. If distance increases, capacitance decreases. If area increases, capacitance increases. So now capacitance of parallel plate capacitor depends on three things. One is area, another one is separation, another one is medium, where these two plates are going to be taken. So you can say principle by taking this formula also. We can increase the capacitance by decreasing the potential. How we decrease the potential means by bringing uncharged conductor and grounding of another side. This is principle. So on this equation also they gave some problems previous year. If you observe, we are going to see. So distance between two plates increases, capacitance is going to be decreases. So this is directly proportional, inversely proportional. So in our channel, that is the first video, how to handle this. C is directly proportional to area, C is inversely proportional to separation, isn't it? So you can try some problems on these equations. We will continue from here in our next class.